build this project, I need my full-size breadboard and T-cobbler. I need two 10mm push-button switches, a 470 ohm resistor, two 1K ohm resistors, one 10K ohm resistor, a red LED, and some wire. I have my breadboard positioned so that row 1 is at the top. The T-cobbler is positioned so that the top 3.3 volt pin in the corner here is in row 3. First, I'm going to set up my positive and negative rails. In this project, I'll be using a positive and negative rail on the left and just a negative rail on the right. I'm going to go ahead and set up the negative rail on the left. This wire is in row 22, connecting to the negative rail. I'll set up my 3.3 volt pin, 3V3, in row 3 in the top left, connecting that to the positive rail. And then I'm going to set up a negative rail on the right hand side using row 19. We're going to control an LED on GPIO pin 23, so I'm going to set up a wire connecting pin 23 down to row 30 here. Pin 23 is in row 10, and then we're going to connect that wire down to row 30. Then we're going to grab a 470 ohm resistor and span the ravine. So I'm connecting both sides of row 30 with the resistor across the ravine. Now I have a spot for my LED. I'm going to position this LED so that the anode, the longer leg, is in row 30 and the cathode, the shorter leg, is in row 29. I'm going to pull this back at an angle there so you can see that the anode, the longer leg, is in row 30 and the shorter leg, the cathode, is in row 29. Now I'm going to connect my LED back to the negative rail using a wire connecting row 29 to the negative rail. At this point, the LED is fully connected. Next, I'm going to add a push button switch. I want to place the button so the legs land in rows 33 and 35. I want to make sure that the legs are pointing to the left and to the right. I've positioned the button so that it's further to the right than it is to the left. It's out of personal preference, and there are other ways you could position this button. Now that I have it lined up, I'm going to press it down. You should feel it sit all the way down to the breadboard. Next, I'm going to connect a resistor coming off of the positive rail and heading into the button. This is going to land into row 33. I've placed a 1K ohm resistor in row 33. It's important that you use the right value resistor. We want to use a 1K ohm resistor. Now I'm going to connect the other side of that button to the ground rail. I head on over here, and I'm just going to go ahead and drop in this wire connecting row 35 to our negative rail. And just want to point out that our path here, when we press this button, will connect the positive rail on the left over to the negative rail on the right whenever I push this button down. So we're actually looking at this active row up here, which is row 33, is joined with row 35 by pressing the button. Now I'm going to connect a wire from GPIO pin 24 down to this button. This wire is going to go from row 11, where GPIO 24 is up top, on down to the top row of this button, which is row 33. We actually have a path from the 3V3 pin headed down the positive rail here, across the resistor, into the button, and out the other side of the button, and up this wire here to GPIO pin 24. The default state of this button actually will be the value true on GPIO pin 24. When we press the button, that path is diverted, and our current will actually travel down to the other side of this button and into the negative rail headed back to ground. So whenever we actually press the button, the value for the GPIO pin will be false. This may sound counterintuitive, that the unpressed button is true and the pressed button is false, but we have a way we can modify that in the code so that it makes a bit more sense to us as we read it. This button has been wired up using what's known as a pull-up resistor. Buttons can be wired with either a pull-up or pull-down resistor. The Raspberry Pi has internal pull-up and pull-down resistors that you can access via code, but we've actually built this one externally. Once you understand how to use them externally, go ahead and start using the internal ones, but for now we're going to look at an external pull-up resistor. And what a pull-up resistor does in our case is it actually ensures that the input pin, which in this circuit is GPIO 24, reads high or true whenever we're not pressing the button. The opposite pull-down resistor will assemble in just a moment, and that will keep our input pin reading low or false whenever the button is unpressed. So we're actually going to have two opposite behaviors with both the buttons. Now that I have the circuit assembled, I'm going to boot up my Pi and get started on the code. So go ahead and boot your Pi. Make sure that you have the T-cobbler plugged into the GPIO ribbon cable. You have your USB mouse and keyboard connected, your video cable connected, and your micro SD card inserted with your operating system installed. Add your power cord and it'll boot up. Remember that your username is Pi and your password is Raspberry. Use Start X to launch the desktop. So I've booted my Pi and used Start X to reach the desktop, and I'm going to go ahead to Menu, Programming, Python 3. If you're using an older version of Raspbian, you can click on the idle 3 icon on the desktop. I'm going to do File, New Window to get a fresh new program. First, I need to use import rpi.gpio as GPIO. You don't need to import time or any other modules at this point. You use gpio.setMode, parentheses gpio.bcm. Next, I need to make a variable for my LED. So LED1 will be equal to our pin number for the LED, which is 23. And then we'll have a variable for the button. So button 1 will be equal to 24, because the button is connected to pin 24. Let's do gpio.setup, so we can set up our LED. So LED1, comma, gpio.out, comma, and then I want to make sure the initial value is set to 0, because I want to make sure that LED is off when the program begins. Setting up the button is similar to setting up the LED. I use gpio.setup, and then button 1, comma, but instead of gpio.out, I'll use gpio.in. I want this code to check whether or not the button's been pressed, and if the button is pressed, I want it to turn the LED on. If the button is not pressed, I want it to turn the LED off. That way, when we hold down the button, the LED is on. When we let go of the button, the LED is off. So to do that, I'm going to actually make a loop here. I'm going to do a while loop. We're going to use while true. I'm going to show you in a minute how to make that infinite loop something that can be broken and still clean up the GPIO pins. But first, I'm going to make my while loop, and then I'm going to go ahead and configure it so that it works properly. So inside of this, I need an if statement. If gpio.input, we're going to read from button 1, so it's going to check the value of our input pin. And I said that whenever the button is pressed, it actually reads false, because when the button is pressed, it's directing the current away from the input pin into ground. So if it reads false, I want to turn the LED on. So we'll use gpio.output LED1, and then we want to set that to true. So that turns the LED on. Then I have this else condition, so anytime the gpio.input button 1 reads true, meaning that the button is not pressed, it's going to follow what's inside of this else. Inside of else we have gpio.output LED1, comma, false. So anytime that the button is not pressed, the LED will be set to off. So I said I want to make sure this infinite loop works in a way that actually will protect our pins by using GPIO cleanup whenever we go to finish the program. So rather than use a keyboard interrupt and just have this program stop, I'm actually going to use a special tool called try except. So first I'm going to highlight everything in the while true loop here. I'm going to indent it. Just using tab, indent the whole highlighted block of code. And above this, I'm going to add try colon. So it's going to try all of the code inside of here, and there's going to be an except condition, which I'm about to add. So it'll run the try until the accept condition pops up. And our accept is accept keyboard interrupt. And the keyboard interrupt is Control-C. So anytime you use Control-C, it's going to go to this accept keyboard interrupt and run what's inside of here. So I put a colon, and then I'm going to put gpio.cleanup. This will ensure that whenever we go to actually terminate this program, that it cleans up the pins and sets them back to their default state. So this is a way we can use an infinite loop like while true, but still exit the program while cleaning up the pins and setting them back to their default state. So I'm going to go ahead and say File, Save As, and I want to name this program Button Light. Now that I've saved my program, I'm going to go to Menu, Accessories, and open Terminal. If you're using an older version of Raspbian, you can use the LX Terminal icon on the desktop. Or if you're on the newest version, there's a shortcut right here. It's the third icon in from the menu. I'm going to run my code with sudo python 3 buttonlight.py. If you want to hit enter, let's go take a look at what this circuit does. So initially, when the button is not pressed, the LED is off, and when I hold down the button, the LED turns on. As soon as I let go, the LED turns off. That's exactly what we intended for this to do. Let's go back and make the program a little better. Looking back at LX Terminal, you want to end this program using Control-C. We didn't get any warnings, we know that GPIO.cleanup is working properly, and you'll see the next time we run this code, we also won't get any warnings about channels left on. So although this program is functional, it's difficult to understand, particularly because we're checking to see if the input pin is equal to false. I want to fix that. There's an easy way to do this. You see, false for us means that the button's been pressed. So I'm going to make a variable called pressed and set it equal to false. Now, instead of checking to see whether the input pin of button 1 is equal to false, I'm going to check to see if it's equal to the word pressed. In this way, this code looks the way that I mean for it to work, and I don't have to remember, is a press button false, is a press button true? And what's great is that suppose I were to redo this circuit to use a different kind of resistor, particularly a pull-down resistor, in which case the pressed value would be equal to true, all I have to change is just this one variable. So if I have multiple instances where it's checking buttons to see whether or not they're pressed or not pressed, storing it inside of a variable makes it really easy to make adaptations to your code as you go. So I'm going to go ahead and save this again. I just do File Save As so you can see it, but you can use any keyboard shortcut you like. And we're going to head back to LX Terminal. I'm just going to recall the code with the up arrow and run it again. So even though I've changed the variable, we can see here that as I press the button, the LED comes on, as soon as I let go, it turns off. We use Control-C to exit out. And now I want to have some fun with this code. Particularly, I'm going to go in and I want to flip it. I want to invert this. I want to make it so that the light is on whenever the button's not pressed and turns off whenever the button's pressed. And there's a simple way to do this with not. So you may remember using not to change the state of an LED. And we're going to use not basically to reverse whether or not we're checking for a pressed button. So whenever the button is not pressed, and it's important that it's inside of parentheses, whenever it's not pressed, the light is going to be on, and whenever it is pressed, it's going to be off. So all I'm going to do is save this and run it again. So here you can see the light is on, and when I hold down the button, the light turns off. It's exactly what I set out to do. Now when I hit Control-C, you'll see that the GPIO.cleanup will run, and the light will shut off. Looking back at my desktop, I want to go over to the program and return it back to what it was a moment ago. I don't want to save this as the not pressed version of the code, so I want to go in and make some changes and actually wire up a different button and run this code again. So I'm just going to save my changes, and if you want to run it again, you're welcome to do so. I'm just going to leave it there and go back to building. So before I start building, I want to make sure that I actually shut down my Pi, because we don't want to build Pi turned on. We want to shut off the Pi, then make changes to our circuit, and then reboot the Pi. So if you're using the newest version of Raspbian, you can find the shutdown, go into menu, and if you're using an older version, you can find the shutdown icon on the desktop.